everybody. I want to give you a little mini lecture on confidence intervals and get us started on those assignments. So let's take a look at what we've got. Okay, first of all, what on earth are they? One way to think of these is that you're trying to predict the mean or the proportion or the standard deviation of a population. So for example, it says down here how many people in Arizona are in favor of legalizing marijuana. You could possibly go out and ask every single person in the state of Arizona. You can see that would be really hard to do though. Some people are out of town, people move in and out. Okay, it takes time, it takes money. So you can't really do that with everybody in the state. So what do you do instead? You take a sample. Okay. Another example, what's the mean salary of a tech worker in Indiana? Again, finding every single tech worker and, excuse me, and asking them what their salary is not going to be easy to do. So you do these with samples. But like we've talked about before, your sampling is usually not perfect. Sampling it well is hard to do. So you have to find out how far off your answer could be and how confident you are that your answer is somewhat correct. Okay, and that's what a confidence level does. So here are some examples of what confidence levels are as answers. First of all, they have a couple of things. They have a value called a point value, they have a margin of error, and they have a confidence level. When you see these in the newspaper, in the popular press, you usually don't see the confidence level, okay? But the confidence level is always in the background. So here's an example, maybe with that legalizing marijuana. And remember, these numbers are totally fictitious. I just made it up. So maybe 76% of Arizonans are in favor of legalizing marijuana with a margin error of 3% and a confidence level of 95%. So you could write this as 76% plus or minus 3%. Or of course you could write it as 0.76 plus or minus 0.03. That's one way to write it. Another way to write it is in terms of an interval on a number line. If you take 76 minus 3, you get 73. And if you take 76 plus 3, you get 79. And so the interval on the number line starting at 73% and heading up to 79% would be your confidence interval. Or if you were thinking of it in terms of ratios, this would be 0.73 up to 0.79. So here's your number line. This would be 0.73 on your number line. Here would be 0.79 on your number line. And these values in between, okay, would be your confidence interval. Okay, you can do the same thing with the mean salary of tech workers. $96,000 with a margin of error of $4,000, a confidence level of 90%. So again, you'd take 96,000 plus or minus 4,000. That's one way to write it. And then the other way you could do it is 96,000 minus 4,000 is 92,000. And 96,000 plus 4,000 is 100,000. So you could write it as either an interval or as a number plus or minus a margin of error. They're both the same way. Notice on both of these intervals that this point estimate is exactly in the center of the interval because it's plus and minus the same amount. So the point estimate is always in the exact center of whatever confidence interval you have. All right, moving on. Here's the idea in real life. First of all, you decide the confidence level. Okay, I'll talk about what that means later on, but that's something that you would typically control. What do you want your confidence level to be? And we'll talk more about, and in the homework they'll give you one, and like I said, more on this later on. We'll talk a little bit more. Then you find your point value. The point value is the statistic that you get from your sample. Sorry about my bad handwriting. So in the example above, okay, with the Arizonans, if you went out and you polled a bunch of Arizonans and you found out that 76% of your sample was in favor of legalizing marijuana, that would be your point value. It's whatever you get from your sample. And then the margin of error is calculated a few different ways. Alex will help you find the correct margin of error on these homeworks, and I'll show you how that works in a little while. Okay? Here's kind of a touchy-feely picture idea of what a confidence interval is. So maybe you want to know how many high school students have texted while driving in the last month. Okay? You go out, you get a sample, a random sample of 150 students, and 45% of them admit to having texted, and you want a 95% confidence interval. Okay? This is your point value right here. So that's going to be the center of your confidence interval. So let's think about if this were a normal distribution, a bell curve, the 0.45 would be right in the middle based on your sample. Now, for a 95% confidence interval, I want this interval to span 95% of the area under this bell curve. The area under this bell curve is 1, the total area. Same as 100%. So I'm going to take the center 95%. I'm going to figure out where the center 95% is. And the cutoff values down here, whoops, let me change that back to black. These values make your interval. So here would be your margin of error here, this distance, and you'd have your margin of error here would be that distance, and the entire thing in the center 95% would be your confidence interval. Now, doing this in real life isn't easy to do with the numbers that you've got, but what we can do is we can change everything into a z-score. Okay, or we'll have a couple other distributions called a t-score and a chi-squared score. But we can convert everything on this thing into a z-score. And for a z-score, the mean would be a 0 and the standard deviation would be a 1. So we can find the z values that go along with those two spots. And once we find the z values, then what we do is we convert back into our actual data values. Okay? All right, let's take a look at the confidence level. So there's a picture of what we want. Now, what on earth does that 95% mean, that confidence level? Suppose back here in the touchy-feely picture example, somebody else took a sample. They sampled 150 students, but they got not the same students. Well, just like on your week 2 DQ, when you had the random dice roll, you wouldn't expect to have the same mean every time because you have different samples. So in this case, they would have a different value from their sample, and all the numbers on this interval would be different. They would get a different answer for their confidence interval. Okay? So suppose they had 52%. So yours, here's a 46% or whatever you had. They had a 52%. Their confidence interval is going to be much different than yours. Okay? So here's what a 95% confidence level means. If you kept repeating this process with every possible sample of 150 students, every possible one, that 95% of the intervals you construct would actually contain the true percent of all the high school students who admitted to texting while driving in the last month. Okay? So out of all possible samples. Each sample gets you a different confidence interval. 95%, since we're talking about a 95% confidence interval, would contain the actual true value of the population mean. Or in this case, we're looking at percent, so the population percent or proportion. Okay. So maybe because of our sample, maybe our mean isn't inside, our proportion isn't inside our interval. Maybe it's inside somebody else's. But 95% of the time we would capture the true value that we're trying to predict. Okay, there'd still be a 5% chance that our interval would not contain that value. Okay, let's talk about sample size, margin of error, and confidence level, how they're related. If you need high confidence, your margin of error is going to have to be larger. It means you'll have less precision. So I lose my keys a lot, and here's how I think about this. Maybe I'm in the city of Phoenix and I lose my keys, and I know they're somewhere in the city of Phoenix. I'm very confident that they're somewhere in the city. I can feel really good, but I have much small precision, okay, with that high confidence. Maybe I think, well, maybe they're on the block that I live in, okay? That's a smaller margin of error, but I would also have less confidence because I've been a lot of places during the day. That's the idea. I've got another example on the next slide you'll see also. So if you need high confidence, you pay for it with a large margin of error. If you need a small margin of error, you need very high precision, you pay for it with confidence. You don't have as much confidence. Now, there are ways to control for both of them, and that's by sample size. If you have a very large sample size, you can keep both the margin of error and the confidence level small. But as we've talked about before, sample size is expensive and time-consuming and not always easy to do. So usually there's a trade-off here between these two things. Okay? All right, here's an example. So here's Garfield taking a look at tomorrow's weather. The high temperature will be between 40 degrees below and 200 degrees above. So here's negative 40. Here's 200 degrees. Okay, there's my confidence interval. You can see it's a very wide confidence interval, right? My margin of error is large, but because I lose that precision, I have a large margin of error, I have a high confidence that I'm going to get the right answer. Make sense? Big target is a big margin of error, but easier to hit the target. Okay? Small target, small margin of error means it's harder to hit the target, and that means your confidence is smaller. All right, cool. There's my joke for the day. Let's move on. Okay, let's go back to find this margin of error. Not every type of confidence interval uses the same value. When I gave the example above with the high schoolers texting, we used proportions and we had a normal distribution. But there are situations where you don't have a normal distribution. You have to make some kind of a, some kind of a compromise, not a compromise, an adjustment to make your answers a little bit more precise. So here's how to know what to do. If we're working with proportions, that was the students, the percent of students who admitted to texting while driving. So if you have a percent or a proportion of some kind, you're going to use a normal distribution, which is a z-value. If you are looking for means and you know the standard deviation for the population, okay, then your margin of error, you're going to use z's as well. Okay. Oh, this is for means And for proportions, your margin of error is going to be the z-value of your confidence level times the standard deviation, but when we're working with proportions, we know that the standard deviation is p times 1 minus p. Whoops, 1 minus p. And we're going to divide by the square root of n. So that's a square root sign there. Now, if you know, so these are formulas we're going to need to have, and we'll use them in a little bit. Okay, here's another situation. We're looking at means. Maybe we want the average salary of a tech worker in Indiana. Okay, if we do not know the standard deviation of the population, we use what's called a t-distribution. All right, and the formula is very similar, except we use a t instead of a z, and I'll show you how to find those later. When we're looking for a confidence interval for variances, we use what's called a chi-squared. That's the Greek letter chi right there, chi-squared distribution. This does not have a margin of error. You calculate these a little bit differently. Let's look at an example now. So I want to look at number 2 in the homework. Let me pull this up and let me pull it down so you can see it. And let me copy it and put it here so that I don't have to go back and forth so much. Okay. So we have a situation. We're working with the population mean, and the population standard deviation is known. That means we're going to use a z in our answer. Okay. So what happens? We've taken a random sample size of 95. We have a population that's normally distributed, and we know that the population mean is 140. Okay, that's the population. We secretly know that. Okay, we also know that the population standard deviation is 23. If we see a sigma, that's going to tell you that that's the population standard deviation. If you see an S, that's not the population standard deviation. That's the sample standard deviation. So that would not be this situation. So you're going to look for a sigma. Okay? So that's what we secretly know about the population. We go out and we take a sample, and we get a mean of 138.5. Okay, so we have an n of 95. We have a mean of 138.5. It's not the same as what the actual population and the population mean is, because it's a sample. We don't have everybody there. Let's get the 80%, and they want the 80% and the 95%, but I'm only going to do the 80% here. Okay? So here's the idea. Here's the picture you should have in your head. This is my point value, 138.5. It's going to go right here. We're looking for a 80% confidence interval. So I want to find the middle 80%. I'm going to convert into z-scores. When I convert to z-scores, this becomes a 0, and I find these two values. Okay? Those are called critical values. Okay, and they tell you right here, for 80%, you're going to use 1.282 for an 80% confidence interval. So I know that this value here is 1.282. That's the cutoff. And here's the cutoff here would be negative 1.282. So plus and minus. 80% in the middle, that means I've got 10% here and I've got 10% here. Okay? Once I've got that 1.282, I'm going to convert back. Okay? My margin of error from the slide above, because we're working with this, there's my critical value times sigma divided by the square root of n. So my critical value is 1.282 plus or minus 1.282 times the sigma, which we know is 23, over the square root of n, which is 95. There's my margin of error, whatever that is. All right, I just grabbed my calculator, and that comes out to be 3.025199, blah, 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 and so forth. So plus or minus 3.0252. That should be large enough. And my confidence interval now is going to be, there's my point value, what I got from my sample, 138.5, plus or minus the margin of error that I just calculated from that formula, 3.0252. Let's make it a 3.03 since our mean only has one decimal point. And then I'll subtract and add. 138.5 minus 3.03 is 135.47. And then 138.5 plus 3.03 is 141.53. All right, now let's take a look at this example. The actual mean for the population, they told us as a secret, is 140. 140 is inside of our interval. Okay, so if you were to take a different sample and do this, you would get a different interval. If you were to take a different sample and do this, you would get another different interval. Every time you do this, you would get a different interval because you would have a different mean from your sample. And we have an 80% confidence interval. So 80% of those samples should contain the 140 inside of it. This one did happen to do it, but 20% of the time, those intervals will not contain the true population value inside. Let's put this into ALEKS. So they want us to make our interval, enter the lower and upper limits on the graphs to show each confidence interval. Write your answer with one decimal place. 135.5 it looks like. And my larger one is 141.5. Okay, and then for the point red dot on this one and then blue dot over there, we're going to enter the population mean 140. Okay, so you can see there's our interval. You can think of a little normal distribution above this, and our population, our sample mean is right in the center. Okay, but the actual population mean happens to be in our interval, so we got lucky. Okay. So that's how we're going to do that. You do the same thing for the 95%. They give you the critical value there for the 95%. So you would just repeat this with that other critical value in that case. Okay. Let's look at part B now. It says press the generate samples button below. So they're going to randomly come up with a whole bunch of samples. Generate sample. So somebody else went out and sampled people and got 139 for their mean. And when they do this process, they get an interval of 136 to 142. Okay, on the number line, that's their interval right there. Okay, somebody else went out and sampled different people and they got 139.6 for their sample. And their interval would be 136.6 to 142.6. So this would be their interval right there, and so forth. So each person has a different sample. They get a different interval. And then here the intervals stacked up as though they were on a number line right there. And the red dot is the true population mean. Now, what I said before is 80% of these intervals should contain the true population mean. We've got 20 of them, and there are, let's see, 1, 2, 3, 4, 5, 6 that don't. So 6 and 20 is 12%. Okay, so we did a little bit better than 80%. The reason that it's not exactly 80% is because there are way more than 20 samples. If I took more samples, I would get exactly 80%. I only have 20, so I'm going to get around 80% of these intervals are actually going to contain the true mean. Okay, so that's what's going on there for part B. That's what we should notice. Don't have to do anything for part B other than look at it. So part C, notice that for 19 out of 20, 95% of the samples, the 95% confidence interval contains the population mean. Is that true? Let's see. We have 20 samples here. It looks like 1, 2, one of those must actually hit. So 95 of them contain the population mean, if I were to count them up. So what's going on? When we construct the 95% confidence interval, it's possible that more or fewer will contain the population mean. Yes. Okay, because we only have 20 samples, we don't have every possible sample. When constructing the 95% confidence interval for 20 samples, exactly 95%, only if I had every single possible interval, so no. When constructing 95% confidence interval for 20 samples, at most 95 will contain the population mean. No, that's not true either. In fact, for the 80%, we did better than 80% when we looked at those intervals. All right, let's look at the last part. Pull this up. Okay, the 80% confidence interval is narrower than the 95% confidence interval. A narrow interval means we have a small margin of error. Okay, it says this is a coincidence. Oh, no, that's not true. Let's come back to here. Small margin of error would be a narrow interval, means low confidence. So a narrow interval means low confidence. A wide interval has wide confidence. Let's come back to the homework now. So that first one's not right. From the 95% confidence interval, we cannot say there is a 95% probability that the population mean is between those values. That's true. We cannot say that. Okay? What we can say is that 95% of all possible intervals contain the true population mean. It's a little subtle difference, but we have to be very careful with that language. Okay? If there were a sample 21, if there was another sample and they had a mean of 190, then the 95% confidence interval would be wider. That's not true. The margin of error does not, whoops, I take it back. The margin, that would be true. That would not be true. Let's come back to our samples, standard errors. Sorry about this, everybody. Here we go. The margin of error is the confidence level times standard deviation divided by the square root of n. So when my n gets larger, that means my margin of error gets smaller. So this would be wrong because they're saying wider. What would happen is it actually would get narrower. Okay. The 80% confidence interval for sample 12 does not indicate that 80% of the sample 12 data values are between 138.5 and 144.5. That's not true either. Okay. And well, it's not true, but they said it does not indicate, which makes the sentence true. All right, let's check our answer. Let me slide this up so I can get to the check. Okay, I didn't do the 95% confidence interval, so it's going to tell me that that's wrong. Everything else should be correct though. Yeah, it says the 95% confidence interval is incorrect because I didn't do it, but it didn't indicate that anything else was incorrect. So go me, good job. Okay, I hope that's helpful so far. Got a little bit more to talk about. The ALEKS calculator is very helpful. Let me get rid of this picture. Delete all ink on slide. There we go. We've done that already. Let's go to the next. Okay, let's talk about using the ALEKS calculator, because there are some distributions that you're going to have to find the areas, okay, or find the critical values. So here's the idea. Okay, this is from the last unit, but the probabilities are the areas. The critical values are on the horizontal axis. So, for example, if they told us that we had a z-score of negative 0.23, there's my z-score. Okay, if we wanted to know the proportion above, the probability that we have something above 0.23, or the probability that we have something below 0.23, we can find this in the ALEKS calculator. It's very cool. So I want to just go to the calculator and show you where you're going to find these. If you need areas, those are probabilities. So this row in the calculator right here for z, t, and chi-squared will give you areas. If you need critical values, the critical values are up here. Z, t, and chi-squared critical values are up here. Okay, the F distribution we're going to look at much later in the course when we get to ANOVA, so we don't need to worry about that. But the Z, T, and chi-squared are all right through here. So let's take a look at what I have here. We have a Z distribution. We have a Z value of negative 0.23. I want the area, the yellow area and the pink area. So because I want the area, I'm going to use the probability. And it says the probability that Z is less than, we want the area less than or equal to 0.23. So I'm just going to put my Z value in there and press enter. And there's my probability, 0.4090, and that's the probability that Z is less than my value. So this is my 0.40 for whatever it is. Okay. What if I want the area that's larger than that? The calculator doesn't tell me that. The calculator has a less than here. If I need the area above that, no problem. The total is 1. 100%, right? So the total is 100%. So here I'm going to take 1 minus 0.404. 1 minus 0.404 is 0.596. So this area is 0.596. Okay, that's how we're going to use the calculator to find probabilities. Probabilities are areas. Okay, does it make sense that this would be more than 50% right here? It should, because look at where my Z value is. My Z value is negative, and for Z scores, the center is always a 0. So I've got more than half of the graph more than half of the graph shaded for the yellow and less than half of the graph shaded for the pink. So that should make sense. Oh, that's sorry about that kitty there. Okay, let's look at another example. Maybe they go the other way. Maybe they tell us that, I don't know what the values are, so I'm just going to erase those. Maybe they tell us that this area is 17%, and we need to find the critical value. That's where I'm going to use the other row in my calculator. All right, so we're working with the Z distribution, so I'm going to press Z. Whoops, let me get rid of that. We're working with the Z distribution, so I'm going to press that. I'm going to look at the area, 17%, but we want the area that's less, so 17% above means that we have 83% below. So I just put my 83 in there, and I get a negative 0.95. Wait a minute. Nope, I'm sorry, I put the 17 in. And that gives me 95.416. So this is 0.95416. Okay. Alrighty. Now, there are some places where it is easier to use the Excel template that I gave you. Not always, but there are a few. So I want to just show you how to use the template for this. Okay? But you can do all of these with this process that we've done. It's just that you would have to look up the critical values with the calculator first. All right, so using the template defined confidence intervals, we have 3 different things to look at. If we're working with means, first we look to see if we know the standard deviation for the population, not the sample. We always can get the standard deviation for the sample. So we want to know if we have the standard deviation for the population. If we do, then in Excel, we're going to use the Z-Test1 sample page. If we don't, you're going to use the T-template page. For standard deviations or variances, we're going to use the standard deviation page. There are none of those on our homework, so you don't have to worry about those. Let's come back and let's do homework number 2 again. So let me find homework number 2. Close the calculator out, slide up, and I'm just going to find the confidence interval. Okay. If you do not know the critical value, you can use the template to do this. So we're going to do some analysis first. Are we working with means or proportions? We're taking a random sample size of n from a normal population that has a population mean. Okay. Our sample mean, so we're working with means. That's the first thing. So since we're working with means, do we know the standard deviation for the population? We do. It's 23. We're working with means. We know the standard deviation for the population, so we're going to go to the Z-Test1 sample on the template. So let me open that up. Z-Test1 sample. You're going to see a lot of things in here. Okay, we can use this for many things. Next week, we're going to look at hypothesis tests. So that's what we're going to use next week. This week, we're working with confidence intervals. So you're going to come to the rectangle that has confidence intervals because that's what we want to have. So it says the sample mean, X bar. Oh, we have that information. It's 138.5. So right here, I'm just going to type in 138.5. Do we know the sample size? Oh, we do. N, there it is right there, 95. Do we know the sigma? Oh yeah, we do. It was 23. So we're going to put that in. And do we know the confidence level? Oh yeah, we're doing an 80%, so I'm going to put in 0.8. Here's my confidence interval right here, 135.475, 135.5, there it is for the low value. For the upper limit, 141.52. There it is, there's my 141.52. So this is a much quicker way to get this. Let's look at this Z star right here, 1.28155. Look at what they're saying here. Use 1.282 for the critical value. So this template also tells you what the critical value is if you need it. Okay. Now, if you don't know the population standard deviation, you're not going to use this page. You're going to use the T template, which is right next to it. And again, it has a whole bunch of things, but this week we're working on confidence intervals, so you only need to focus your work on the part that says confidence intervals. So our mean, our standard deviation, our N, okay, our confidence level, okay. DF stands for degrees of freedom, and T star is our critical value right there. There's the critical value, although for most of the homework they give it to you on ALEKS. There's N right down here, these two make your confidence interval for that, okay? All right, I hope that gives you a good start on the homework, and I'll see you in class, and let me know if you've got questions, okay? Thanks so much. Bye-bye.